So we have one last part of this unit, and we're going to finish what we started yesterday. So we're going to talk specifically about this function right here. And by the way, same exact thing as y equals log base a of x. Okay. Sometimes it's helpful to think y instead of f of x. Okay. And now remember that this is the inverse of the exponential function y equals a to the x. Okay? So to understand the graph of the log function, it's actually easier to first revisit the inverse of that, which is the exponential function a to the x. So if you remember graphing this, I know we've been using the calculator, but we can easily make a table plugging in these three basic x values into the equation, right? Let's start with the easy one. If I plug 0 in, what's a to the 0? 1, right? Anything to the 0 is 1, right? What's a to the 1? A. And now what's a to the minus 1? Not negative. 1 over, right? It just makes it the reciprocal. Okay? So remember, we're using a, but this applies for 2. Like if this were a 2 to the x, we saw 1, we saw 2, we saw a half. Those are the main y values, right? Now, if this is the table, or these are the 3 points that we can use to graph this, I think these will make sense now, right? Because these are what? They're the inverse points, right? Because the x's and y's just flip around. So instead of 0, 1, we got 1, 0. Instead of 1, comma a, we got a, comma 1. Does that make sense? Instead of negative 1 and 1 over a, it reverses. So now we have that as part of the log graph. Okay? We have an asymptote of x equals 0. Because remember, the exponential graph, so let me quickly sketch it, looks something like this, right? Remember that we had horizontal asymptote at y equals 0? Well, if we're doing the inverse, instead of a horizontal asymptote of y equals 0, now it's x equals 0, because everything flips, right? Does that make sense so far? Okay. Now, let's just, this is important, you should know this, but I think it'll help when we start doing this example, okay? So let's first start by doing y equals 2 to the x, okay? The 3 main points that we would graph for this one are 1, 2, right? What else? I'll do this one in pink. Let's make a table first, maybe. Negative 1, 0, 1. What are the points? 1 over 2. Okay, so 1, 2. There it is, right? 0, comma 1, right here. Negative 1, and now we're up a little bit, but not quite on the x-axis. And so we get this. Okay? The inverse, which is log base 2, okay, is going to be this exact table, but backwards. Okay, so 1 half, negative 1, 1, 0, and then 2, 1. Okay, so if you plot those points, right a half down to negative 1, 1, comma 0, and then 2, 1. Okay, Remember that instead of having a horizontal asymptote, now there's a vertical one at x equals 0. So as we go back to the left, this is just going to get closer and closer to the x-axis. And now this one's still going to keep going up, but just not very fast. Do you guys remember what that mirror or symmetry line is for the inverses? Very important, right? When you graph a function and its inverse, there's a line that's always like the line of symmetry or the mirror line. What's that equation? There we go. Okay. So remember, if you're doing a good job graphing logs and their inverses or vice versa, you should have, the same exact picture on each side of that y equals x line. Okay? Let's fill in the domain here. The domain for y equals 2 to the x, so the pink one, right? What's the domain? All real numbers, yes. What's the range? 0 to infinity, very good. What's the x-intercept? It does not have one. What about a y-intercept? Okay. And again, y equals 0 is the asymptote. Okay. So if we can remember those details about the exponential, again, just flip everything around for the inverse, log base 2 of x. Now instead of the domain being all real numbers, that would be the range. Okay. And you can see that on the blue graph, right? We go all the way down to negative infinity, and now this is just going to keep going up slowly to positive infinity. Okay? Do we have an x-intercept now? The y-intercept becomes the x-intercept for the log graph. And I forgot to fill in the domain. The domain is 0 to infinity, which used to be the range, right? Y-intercept now is none. And instead of y equals 0, our vertical asymptote is x equals 0. Okay? Does that make sense to you guys? Yes?
How do you, like, for when you make the tables?
Yep.
Are those like set numbers? How do we know what those numbers are?
Which ones?
Like for the pink one?
Mm-hmm.
You just always use negative 1, 0, 1.
For x? Yeah, those are good places to start. Yeah.
So 2 to the power of 1, negative 1 is half.
Yes. Yes, that is correct. Remember that a negative exponent, let me make sure we're in the right color here. A negative exponent means reciprocal of 2 to the, in this case, 2 to the first. Right? If it were 2 to the minus 3, let's say, it would just be the reciprocal of 2 cubed. So 1 over 8. Okay, negative exponents don't mean negative values. It just means flip the fraction around. And so now we get a smaller value. Okay. Let's do this without graphing. Okay. I think we can do that, right? Y equals 3 to the x. What's the domain going to be? What's the range going to be? Any x-intercepts? Y-intercept? And? See how easy this is? So now, if we're doing the inverse, which is log base 3 of x, just as easy, just flip everything around, right? Domain is 0 to infinity. All real numbers for the range. Oh, and I used pink. I am sorry. There we go. Now it'll be sort of a purplish hue. Okay, x-intercept, 1, 0. Whoops, no. y-intercept, and x equals 0. Okay? So, again, as far as the graph goes, these are so easy that you can do them by hand. It might be even faster than like going into the y equals menu, typing it in, and looking at your points, right? Just make a quick little table when they're so simple like this. Same values, Jackson, right? Pretty good place to start. What's negative 1 going to give us? 1/3. And then any base to the 0, 1. And then 3 to the first, 3. So when you graph those, same shape, just a little steeper, right? So here's the graph for 3 to the x. And now for the inverse, just reverse the table. 1/3, -1, 1, 0, 3, 1.
For the y-intercept, so on the left there's a vertical shift up or down, then the y-intercept will always be 0 to 1.
And let's actually, I like what you're saying. Let's take one case out of that. Only if there's a shift down, right? Because if it shifts up, there's still not going to be, are you talking about the x-intercepts?
No, the y.
Oh, the y-intercept. For the log?
No, for the exponential.
So is it always 0, 1? Is that your question? Okay, sorry. I thought we were talking about the asymptote. So yes, unless it shifts up or down, you are correct. It will always be 0, 1. And if you know it's always at 1, if you know how much the shift is and which way, you don't even have to plug it in. You should just know, oh, it's up 2, so now it's at 3 instead of 1. Okay? Good question, David. Okay. And so if I finish this graph, it should look something like this. Okay? And there's my symmetry line, right? Any questions? We've already answered this question, by the way. Everything reverses for exponentials and logs. Okay, we've been using that to help us graph these. Okay? Let's go to the second page. Yeah. So I'm gonna try to answer this without the graph. I mean, I'll do the graphs at the very end. I think we can find all the details out, and that'll actually help us get a good graph before we even graph it, okay? So remember, if we're looking for the domain of a log function, what do we do with this? You make it, what's the restriction? Greater than 0, right? You can never have 0 or a negative number in the logarithm. So anytime, I mean, look at it over here. Here we had just an x in there, right? So if we take this x and set it greater than 0, what does that tell me? That tells me the domain is on the right side, right, of the 0 line. Okay? This, if I solve, tells me that now the domain is x is less than, or I'm sorry, greater than -1. Okay? So we could say -1 to infinity. Does that make sense, you guys? Okay. Now look, we could have answered this without even doing that. Because all these, anytime it's just log x, whatever the base is, doesn't matter, but log x, right? We always have x equals 0 as a vertical asymptote. So that means that the graph is on the right half of that, on the right side of that. You guys have known for a long time now that if I add 1 in the function, what does it do? It goes left 1. So instead of going from 0 to infinity, the domain shifts with that. Does that make sense? And now it's from -1 to infinity. Lots of ways that you can think about it. Okay, we'll skip the graphing part for now. The range. What's the range for any log graph? All real numbers, yes. Okay. The asymptote is always x equals 0 unless it shifts, which it just did, right? So now it's x equals -1. Okay. Good question. So if we shift the log graph up, so let's just take any log graph, like this blue one right here. If I shift this up, does it change the vertical asymptote? So that's still 0 for the vertical asymptote. It'll change these main points, but the domain and the range will stay the same. Does that make sense? Okay. Uh-oh. I hope I didn't just mess up the video. Okay. I'll have to check later. All right, so finding the inverse. Okay? This is the first time we've kept saying logs are inverses of exponential. We haven't really actually done it, right, by hand. So let's go ahead and take a look and see why and how it works. So instead of f of x, what's a good thing to call this? Okay, so let's write it down as y equals log base 3 of x plus 1. And if you forgot the steps for finding an inverse, it's in a previous section, right? But first you switch x and y. Once you switch x and y, your goal is to get y alone now, right? Well, I can't really get y alone anymore. I always like to say I'm stuck at this point. There's nothing I can add. There's nothing I can subtract or divide or multiply to get this any better, right? When you reach a point where there's nothing else you can do, that's when you switch the form, you guys. Okay? Once you have the log alone or you're stuck, you switch it to the other format. So that's what we worked on yesterday, right? Yes. How do I switch this from log to exponential now? Base is 3. Very good. Now could I get y alone easily? We just subtract 1, and there it is. 3 to the x minus 1 would be the inverse rule. Okay? Any questions on how we did that? Okay? Now, let's just practice. Forget all these details for a second. Regular exponential graph, right? What is the domain for all exponentials? All real numbers. And this is what David just kind of helped us remember. Unless there's a shift, which in this case there is, right? Now the horizontal asymptote isn't at 0 anymore. It's at -1. Okay? So then now we have a range of -1 to infinity. Let's say I don't like the shifting, right? Could we have figured that out? What happens up here? They switch. They're inverses, so they switch, right? All right. So now as far as the graphing is concerned, once you have all these details, you guys, I'll do the original in pink, and I'll do the inverse right here. I'll do this one in blue. Okay? Let's start with this one because we know this is a lot easier to graph, right? So horizontal asymptote is now y equals -1. Oh, yeah, sorry guys, thank you. Horizontal asymptote is now down a unit, down to y equals -1. Okay, and if you remember this graph for 3 to the x, just shift everything down a unit, right? You can do it that way. Or, if you prefer, you can plug in some points. Okay, but not too bad. If you plug in, let's do 0. If I plug 0 in, 3 to the 0 is what? And then subtract 1. So 0, 0 is a point on the graph. Does that make sense? If I plug in 1, 3 to the 1 is 3. Subtract 1, we get 2. If I plug in negative 1, 3 to the minus 1 is 1 over 3, 1/3. Subtract 1. 1 minus 1/3 is negative 2/3. So now we're down here. Okay, so there's the exponential graph. I'll even label it 3 to the x minus 1. Okay, and now the log graph, if I have this table, I'll just flip everything around, and that's probably easiest. So negative 2/3, negative 1. 0, 0 is still going to be 0, 0, but now I have 2, 1 instead of 1, 2. Okay. So negative 2/3, negative 1. Oh, by the way, instead of y equals 1, what's my asymptote now? X equals negative 1, right? So I'm going to draw that in as a guide. 0, 0 still on the graph. And then 2, 1 is on the graph. So we have something that looks like this now. Okay? So they kind of look like they're intertwined in here a little bit. And that's okay. They're going to do that from time to time. Okay? Does that make sense? Okay. Why don't you guys try... Why don't you guys try this next one on your own? Okay? Let's see what you guys can do with it, and then I will go through it real quick. Okay? Remember, just to make sure, is this plus 1 inside? So if it helps, I would recommend putting little parentheses around the x so that you don't get confused there. Okay? Up.
It's up. We have one. It's not on that side.
Give it the purple.
No, no, I ate it. Huh? Yes. For which one? Yes.
I hear some good stuff. Yeah, what's the base here?
E.
E. Good.
How do you know what greater than 0?
Whatever's on the inside of the log.
Okay, but you don't know like the square root, like in order to know that it's cubic, you have to have three.
Did you do a video on the notes yesterday?
Yeah. Yeah, please, if anybody else missed yesterday,
Yeah, we were here.
okay, there's a link on our calendar, which I know we all visit every single day before class.
Yeah.
Okay? There's a link to what we did in class yesterday. Yes, with explanations and whatnot. So if Sam isn't making sense,
I am.
she is. Yeah.
No, not the one. I'm saying Ellen. E, so like If you see the R, you know, the R. No, it's disgusting. No. But you know how like, so you know how there's a square root and you don't technically get the square root, right? Okay, so like that's why they're opposites here. So ln, every time you see ln, that means it's e. Just like log, every time you see log 10, it equals just log. Yeah, but I already know. Because that's what I learned. Oh, that's my one. Yeah, because you, if it's on the outside. Look, here, relax. Erica, I'm sure. Here, look. This one, we had to like change it. Into the only reason
I
why
thought
I
the
skipped
domain
X
was
equals
negative.
thing because yesterday we learned.
Not for logs.
So like, you see how it's not on the inside of the parentheses?
Where's the one?
So it's on the outside.
So it's referring to this log.
Well, there's no X.
Check your, at the very least, can we get this on without doing too much?
Yeah.
Okay, check your domains and ranges and asymptotes. Okay, everybody got this? Okay, let's go through finding the inverse together. So follow along if you've already tried it. Check your steps. I'm going to go through it real quick. So if I have y equals ln x plus 1, first we switch x and y, right? And is there anything I can do to get y alone, or at least one thing to get rid of? Yeah, subtract the 1 first, right? So x minus 1 equals ln of y. Now there's nothing else I can do to get rid of the log. So at this point when we're stuck, we do what?
Change it.
You switch it, yeah. So what is it? E. There you go. And we're done. That's our inverse. Yeah. That's a good question. So why does a shift up one not affect the domain? Well, domain is, well, do we understand why the domain is the same? Because left to right does not get affected by up and down. But the range is all real numbers. Does that make sense? In other words, if you take negative infinity and add 1 to it, it's still going to be negative infinity.
But what if it was like 2 or something, then it would change.
The range is always all real numbers for logs.
It's like if arrows are going this way and this way, and you shift, it doesn't matter. It's still going to
So you're saying
Oh, yeah,
the
no
domain
matter
is
what it's doing, you're
this way and this way.
Yes.
So
So this plus 1 doesn't
So there's no way of
change the 0 to infinity.
Yeah, that's why I asked that. I was like, oh, what if it's on the outside? And it's like, what's gonna
Okay.
be the difference?
How do you know? So one way to figure this out, remember that the domain, to find the domain, remember we talked about, now we have 3 things you have to know for domain, right? Number 1, fractions. If there's a fraction, the denominator can never equal 0. That's one thing we have to know. If there's a square root, whatever's on the inside of the square root has to be greater or equal to 0. That's a rule, a law, so to speak, right? For logs, we can never have a 0 or a negative in there. So that means that whatever this is, x, or in this case, x plus 1, right? We set it greater than 0. And that is the domain. And so if x is greater than 0, you translate that to interval notation, right? That's 0 to infinity. Okay?
Why the domain is, why there's the restriction?
That it has to be greater than 0? Well, here's why. So let's start with this. Okay? So David asks a good question. Besides that, things flip around. Okay, that's one reason to explain it. But why does this have to be greater than 0? Okay? How do I switch this to exponential form? What would it be? To the... Okay. And now this a represents a base, a positive number not equal to 1, right? So if we have a positive number, regardless of what this exponent is, right? Imagine this were a 2. Well, if I have 2 to the something, this is always going to be positive. There's no way we're going to get 0. There's no way this is going to be negative. Does that make sense? Because think of the graph. 2 to the something, right, equals y. Remember the table that we did? Let's call it an x. If I start plugging in numbers, when I plug in 0, 1, 2, this exponent up here, positive, right? If I plug in negative numbers, what happens to this answer? It flips. 1/2, 1/4, right? This will never be negative and it will never equal 0. Now, where is this x really? Well, this x is also in the log, so those are the same rules.
So what will happen if it is less than 0? Does it mess up the whole?
It does. You will never see that.
The whole idea of an exponent.
Absolutely. So if you try typing in, okay, it's automatically going to say, what are you talking about? You're crazy. You can't do the log of 0. That doesn't make any sense. Just like if you try to do square root of -2, right? Your calculator says undefined. You can't do that. Okay? Same thing if you type in a negative. Non-real answer. Okay?
Because you need to have that asymptote.
Yes.
And the only way to get a negative number is to have a number that's negative.
Yes.
Okay.
Exactly. And by definition, for exponential functions, we don't have negative bases ever. We just have positive ones. Okay? All right, so let's talk about, since we're going to run out of time here, let's talk about how to graph these on the calculator. Okay? So this is pretty easy to type in because there's a button for it, right? So we would just do natural log of x plus 1. Okay, and you can graph that. And there's a graph. Okay. Probably a good idea to look at a table. But this one's kind of a messy graph, right? Because E, the base, is 2.718, et cetera, et cetera. So basically this one nice point that we have, the 1, 1, that's the only nice one. After that, it's all just a bunch of decimals, irrational numbers. Okay? So you can use your table as a guide, all right? But also use this. X equals 0. X equals 0 is a vertical asymptote, right? What's the one nice point on here? 1, 1. So you know what I'm going to do? You go to 1, 1. And do we know what shape this is going to have? I would be thrilled if we can all do this correctly, and I would be absolutely okay with you just having 1 point. Is that okay with you? As long as you guys have the shape, right? Like, should you go like this?
No.
What does it do after this point? It curves and it gets, slowly starts to increase, right? And what does it do after this point?
It goes closer to 0.
Yeah, close to the asymptote. That's all I need to see, you guys. So can we do this? That's fine. There's e to the x, or whoops, wrong one. There's natural log of x plus 1, right? And now, what's going to happen for this one? The inverse, well, this is kind of nice. The 1, 1, the 1 point that I graphed, where's it going to go? 1, 1, if you reverse, it's still 1, 1, right? What's the horizontal asymptote for the, instead of x equals 0, now it's y equals 0. So do we know what's happening with this point? Well, to the left of this point, we get closer to the asymptote, and then after, we get steep, right? So if you do something like this, absolutely. Okay? Now, if I asked you, give me 3 points that are on this graph, no, you got a table right here, right? You can use the table to get the points if you need to, or plug them in by hand, e to the 0 is 1, e to the 1 is e to the 2 is e squared, okay? Does that make sense? Okay. I'm going to stop the video here, and I'm going to hope that it recorded.